Hi, I'm Claudia Brancart, a producer from Up to Date, a podcast that covers the topics Kansas Cityans care about most. Every day, we have meaningful conversations with people who define Kansas City. We explore the city's character, which is sometimes complicated and hard to understand. So give us a shot and stay up to date with Up to Date.
Let's travel back to the 1800s. Botanists are looking at this stuff on the roots of trees, like an odd sheath. It's got to be some kind of fungus, they realized. And roots covered in fungus, probably a parasite, right? Bad news for the trees, they figured. But a few scientists did have other inklings. Among them, a professor in Berlin, Albert Bernhard Frank. He had a theory. What if these fungi are actually kind of like a wet nurse, feeding nutrition to trees? Even more than that, it's actually like a two-way street because the trees are feeding the fungi in other ways. And in 1885, Frank publishes his theory. The response was not great. He faced criticism, but he wasn't fazed. And before long, he and a student were finding these fungi on all kinds of plants, not just tree roots, in different forms. It wasn't always a sheath. And it was like they had stumbled onto this whole symbiotic love fest going on underground and making life tick. Unfortunately, it took decades to test and prove a lot of Frank's ideas about this, and he was long dead by then. But it turned out he was right that something big was going on here. And I'm literally pulling this history about him from an article in the journal Mycorrhizae, a journal named with the word that he invented for this plant fungus mind meld. Mycorrhizae, you can pluralize it mycorrhizaes or mycorrhizae. Today, we know that most plant species can form these bonds. Lots of trees, yep, like those very first root samples that Frank wrote about. And you've maybe heard about those because today there's a popular but hotly debated idea that these fungi link certain trees in forests, like oaks and pines, into this collaborative wood wide web. But we're actually going to talk today about another kind of mycorrhizae that Frank's student came across. This other category, it actually turned out to be much more widespread, much more ancient, and from my perspective, much more subtle. You'll never see them while you're out on a hike because these primeval fungi don't make any mushrooms. They do, however, bond with the vast majority of plant species on land, including most of our crops. Corn, wheat, tomatoes, carrots, apple trees. The list goes on. They're called arbuscular mycorrhizal fungi, AM fungi for short, and they show up in the oldest fossils of plant roots. Scientists now think these little microbes are how plants moved from a watery existence onto land, basically opening the door so plants could become land conquerors that turned entire continents green. And this plant-fungi duo has stuck together ever since. That's hundreds of millions of years, the bestest of BFFs. But in recent decades, we've realized that the way we farm and garden today, the tilling, the weed killers, the fertilizer, tears these BFFs apart, which costs us a lot of really amazing benefits. And that's why some farmers and gardeners are rethinking how they work. The soil health movement, as it's called, is all the rage nowadays, and these mycorrhizae are part of it. From the Kansas News Service and KCUR studios, you're listening to Up From Dust. I'm Celia Yopis-Jepsen. Symbiotic fungi fill the ground beneath us, microscopic but mighty. Farmers want them in their fields, gardeners want them in their veggie patches and flower beds, and with all the amazing things these little microbes do, who can blame them? Today we'll learn there's a lot to love about them, but we'll also get a very healthy dose of skepticism because there's now a $1 billion mycorrhizae market vying for a piece of your pocketbook, and the evidence suggests we're wasting a whole lot of money. Scientists say it's time to slap some meaningful rules on this market that's shipping microbes globally. So, where to learn about these symbiotic microbes? Turns out the world's biggest collection of them is right here in the middle of the country, staffed with top-notch super nerds, that's a compliment, guys, on AM fungi, or however you want to say it. What do you normally say?
I say fungi.
Fungi.
4 experts of fungus, and we have a split room.
We do.
I have some friends on the West Coast, they say fungi all the time, and it drives me crazy, but then I start to say it when I talk with them a lot.
This collection,
It's the International Collection of Vesicular Arbuscular Mycorrhizal Fungi.
everyone calls it INVAM for short. That's one of the curators, Professor Jim Beaver. Also here, Peggy Schultz, research specialist, Tara Lubin, associate researcher, and Liz Koziel, assistant research professor. Liz, by the way, totally stumbled onto this field of study by accident.
I just took a random hourly job 15 years ago because I thought I would be studying mushrooms, and then got to the lab and it wasn't mushrooms at all.
So we're in that lab. It's at the University of Kansas, and my lesson starts with a microscope.
So why don't you sit down and take a look?
Put your hand here, so it's relatively low magnification now, and you can crank it up.
Oh, look at you. Hello. They look like pearls. Weirdly beautiful.
They're marbles.
Yeah. Okay, it's hard to hear, but in the background, Liz is protesting that fungi are not, as I suggested, weird. They're just beautiful. They're not weirdly beautiful. How about weirdly to me in the sense that it never occurred to me to think about whether a fungus spore is beautiful.
That's fair.
But yes, they are beautiful. They kind of looked like glass artwork, like these translucent glass globes packed with more translucent globes inside of them.
That's fat globules reflecting the light back at you.
They're stuffed with fat. Some quick spore anatomy. These spores
And they are a single cell,
are brimming with nuclei.
100 to 1,000 nuclei.
That's per cell. Human cells have just one. And some of these spores,
For a single cell, they're really, really strong.
so strong that if you crush the cell,
You can hear it.
hear it? Listen again. That's Liz popping a single cell with a needle like the world's tiniest bubble wrap. So, why are they stuffed with fat? Well, energy. Basically, these spores have a mission. And once it starts, the clock is ticking.
They have to find a living root.
The spores will send out runners.
Yes, that's a good description.
They're sending out arms.
They're sending out, yes, they're reaching
And hope to God they can find plant roots to bond with
in order to continue to grow.
before running out of their fat stores. If they make contact, these filaments, which are called hyphae, are going to do the thing, make the mycorrhizae. They'll push through the tough covering of the plant root and branch out there right inside the root, cheek to cheek with some nice soft plant cell membranes. And when they do that, these AM fungi help not just plants, but ultimately us humans too. A few benefits in short. These mycorrhizae lock carbon into the soil and out of the atmosphere, which happens to be a thing we really need right now to fight climate change. They combat erosion, which, hey, we also really need because we've lost so much topsoil on farms. If you want to learn more about that, you can listen to our episode on the history of tilling and soil loss called Healing the Ground We Broke. Also, these fungi help plants get water and nutrition, survive drought better, even fight off insects better. So, how do they do this stuff? First, a simple rule about plants. Plants need phosphorus, like absolutely need. It's a deal breaker. But getting phosphorus out of the soil around them can be really hard. Enter the AM fungi. They're like the Jedis of phosphorus harvesting. And they're like, okay, plants, we can get you the phosphorus you need, but we're going to do it for a trade. The fungi want carbon, which plants have in spades. I mean, they literally pull it out of the air. So they swap carbon for phosphorus, and both parties get to thrive. Yay. And this trade may be the original reason that plants and AM fungi ever teamed up in the first place. But this bond between them ends up doing so much more than that. Liz says AM fungi send out all these long, stringy, thin hyphae through the soil.
That hyphal network is awesome at making the soil more stable.
And all these hyphae running every which way, they ooze almost like a glue, and the soil ends up clumping.
Exactly. And so there's many benefits to making the soil clumpy.
It helps the soil not wash away in storms, for example. And Peggy says those clumps also open up all these gaps between the clumps.
Sort of ecological niches for other microorganisms.
Gaps in the ground.
Oh, it creates habitat. Yeah, it can create habitat.
That's not the only reason gaps are good.
Water and nutrients can percolate down, and roots can too.
So this clumpy soil holds more water in times of drought and heavy rain. Good for plants, including our crops. But the hyphae of AM fungi are also good for them because they shuttle water and nutrients to plants, including the ever-important phosphorus. And as plants pull carbon out of the atmosphere and put it into the ground, those same gluey clumps in the soil
are what protect those little bits of carbon, keeping that carbon in the soil.
A note about Peggy. She fell in love with these fungi when she was a grad student in ecology. She noticed everyone was so focused on all the competition in ecosystems.
And I just felt like mutualisms are just as important as competition.
Interesting.
Sort of a philosophical desire to explore mutualisms. But I think to really take advantage of AM fungi, we're going to have to change the way we do agriculture.
One of those changes is cutting back on plowing. Plowing decimates things that live in the soil, like AM fungi. Another is laying off chemicals, including herbicide and especially fertilizer.
Because what we know is that when you put a lot of fertilizer on a field, conventional agriculture, these fungi are less beneficial to the plants.
These are not easy changes, depending on the farm and what you're growing. We're going to meet farmers in other episodes who are tackling them. But in short, here's why it matters. Spraying synthetic fertilizer onto a plant is kind of like spoon-feeding it phosphorus. Then the plant is like, great, I've got my phosphorus. Sorry, former BFF fungi, I'm good now, take a hike. So, chemical fertilizer helps us boost yields, but it does come at a cost of these many awesome mycorrhizal benefits. It's also a big source of water pollution.
We seem like nerdy people, perhaps, that care a lot about organisms that other people don't even know exist, but they do have a really important role to play in the ecosystems of the world and in our restoration of native lands and potentially our agricultural crops.
Okay, more about AM fungi in a moment.
Kansas City public schools have seen a lot of turmoil over the last 50 years. There was the history-making federal lawsuit over desegregation, an influx of charter schools, and a hard-fought battle over accreditation. Now the question remains, has the tide at Kansas City public schools finally shifted?
At some point, we got to say, have they not done enough?
We're breaking down Kansas City's strained relationship with public education on the podcast, A People's History of Kansas City.
Okay, our phosphorus Jedis, AM fungi, they're all over the world, busily bonding with most plant species. But for something so widespread, it turns out studying them is pretty complicated.
They're difficult to grow in culture, and so few labs in the United States are able to maintain them on their own.
And that's one reason.
Not much is known about them.
Jim says AM fungi are actually a young and really pretty niche field of study still.
Even amongst people who study fungi, few people study this group of fungi.
Over the decades, INVAM, which has species from 49 countries and every continent but Antarctica, INVAM has become a hub for advancing this science.
Our lab knows how to grow them. By growing them out, we can make them available for people to do research who might otherwise not have access to them.
And they do indeed get requests from all over. Scientists seeking samples or other kinds of expertise and help, academics, private labs, companies, people who are studying agriculture, climate change. Tara fields these requests, which really run the gamut.
We had one person who was interested in growing things on the moon.
Another person reached out with a more immediate problem.
A zoo that was trying to maintain some plants in one of their habitats.
Scientists around the world are also researching how AM fungi can help pack more nutrition, like minerals, into our fruits and veggies, or how these fungi can protect us against heavy metal pollution in soil. They are also using AM fungi to help restore prairies and rare plants.
Get the right key. There you go.
Ooh, cold.
4 degrees Celsius, more or less.
Where are we?
And we're in a big walk-in refrigerator, kind of like you'd find in a restaurant.
Oh my gosh, so many shelves full of clear plastic bags.
Every one of these bags is an individual isolate.
Is that like a species?
Kind of. Some species we have many isolates of, collected from different locations across the world or under different crops, etc.
Keeping this collection long-term is not easy. You can't just cram all these fungi in a fridge and forget about them. I mean, they are alive.
They have to be restarted. Most species have to be restarted every year. So every week we start another 20 cultures.
It sounds like a lot of work. I mean, I tried to do a sourdough starter in my fridge and I killed that. So I'm imagining like endless sourdough starters that you have to take care of.
It's not a bad description of it, with the exception that we got to grow plants on top of the sourdough.
Here's a simple summary of how it works.
These fungi only grow on live plant roots.
So they pull some out of that giant fridge.
We grow them on Sudan grass.
A kind of sorghum.
The fungi and plants grow for about 5 months.
In a special greenhouse with filtered air.
Because some of these isolates, they've been in culture for 30 or 40 years, so it would be horrible if we lost them because of contamination.
We grow them until they produce their spores.
Then they dry down the roots and soil full of hyphae and spores.
Bag them and store them in a cold room.
And yeah, it's a constant dance. Out of the fridge, grow, harvest, back in the fridge, out of the fridge, grow, harvest, back in the fridge. That is how you keep 1,000 different kinds of fungi gathered from prairies, savannas, forests, deserts, you name it. It is a very diverse collection that is honestly still just a snapshot of what's out there. But all the work pays off. And the more scientists here learn, the more details they can publish to the INVAM website for the whole scientific community. How to identify each specific species under a microscope, how to grow them, how to harvest the spores.
It's all there.
It's the how-to manual, how to do this.
Exactly.
Yeah. At this point, INVAM has been cited in thousands of academic papers by researchers using its samples or its methods, etc.
And it was something like 5,000 different citations from all over the world investigating all sorts of different things.
So, scientists have toiled away on this stuff for decades, feeding these fungi like endless sourdough starters, piecing together all the wonderful, nerdy details of how AM fungi shape our world. But for the rest of us, I mean, these microbes are mostly pretty obscure, right? Still, lately, I kind of feel like mycorrhizae are having this breakthrough moment. There's been popular science books and documentaries, podcasts, and I just read a best-selling horror novel where the big reveal at the end was mycorrhizae invading people's brains. I won't tell you which book because I don't want to spoil it. But more than a cultural moment, mycorrhizae are having a money moment.
I think it is catching on that these microbes are important. There's a huge mycorrhizal inoculant industry.
That's Liz again. The soil health movement is big business nowadays, and just the mycorrhizae stuff alone, that market, it's booming.
$1 billion globally.
$1 billion annually. This industry sells spore products to put in your soil, wooing us with promises of better harvests that are eco-friendly, so our soil will thrive and our prized flowers or vegetable patches or crops will flourish, even in drought, and without a bunch of chemicals. But buyer beware. Concerns have been circulating about some of these products for a long time.
Let's see.
So Liz
Open this one.
decided to do some sleuthing.
So for this trial, I just went to Amazon and bought the, 16 most popular products on Amazon at that time. This was in maybe 2020.
She picked up products at hardware stores and trade shows, too.
It's a powder that smells strange. Here's a liquid product. Really big granules. And those you would usually apply like a teaspoon or a tablespoon per plant, for example, versus the liquid things are more likely to be put inside a large farm implement and then surface sprayed across the field. Another liquid.
It's safe to say that AM fungi stored in liquid will be dead. There's no way these are alive unless they're kept in a cold room.
This is a jar of powder that costs hundreds of dollars and that we found to not have viable fungi in it.
No viable fungi. Liz knows because she put products to the test under the microscope and in the greenhouse.
And then I grew lettuce and carrot and sorghum with all these products.
Then she waited for the spores she bought to do their thing. But the commercial products were pretty disappointing, right?
The spores were dead. So when you looked at the roots of these plants, they didn't have any of these wonderful mycorrhizae helping them out.
So that's true. Some of these spores were dead in the products. They had spores, but they were non-viable. But it goes a little deeper in that some of these products never had any spores at all. Because we can find dead husks of spores if they're present.
The products produced mycorrhizae about 12% of the time. A bunch of the brands never produced anything. And it's possible some product sellers are accidentally killing their spores. A lot can go wrong in the process of cultivating, packaging, transporting, and storing these things.
Yeah, we need to figure that out. Because these fungi can do awesome things for crops, but not when they're dead.
If you want to know more about this, for example, if you buy mycorrhizae online, we've got an in-depth article about this on our podcast page with info about specific brands, and a couple of the companies also talk to us, so you'll want to check that out. Back to Liz's findings. They are not a fluke. KU scientists combed through 250 commercial product trials published in peer-reviewed journals. Most of these trials check to see if any mycorrhizal fungi materialized on plant roots and helped plants grow. And 88% of the time, the answer was no. Academic scientists are finding other problems in these products too, beyond dead or missing spores. Some contain microscopic parasites that can attack your plants. Others, and this is the issue I find most ironic, contain undisclosed chemical fertilizer. A problem because, one, putting fertilizer on plants totally screws with mycorrhizae, as we explained earlier. Two, here's Peggy again.
People are spending a whole lot of money to buy phosphorus and nitrogen, which is a whole lot cheaper if you just buy it.
Basically, if you're paying mycorrhizae prices for fertilizer content, there's a good chance you're getting gouged. And it might be hard to know if that's what you have because that can obviously still help plants grow, even if it is chemical fertilizer and not fungi that's doing the job. Now, it's not that there are no good products for sale. The problem is those of us who can't put them under a microscope and do these kinds of experiments with them, how are we supposed to know what to buy?
There's really no regulation in the U.S. to hold them accountable to what they say on their product labels.
Liz recently argued in a scientific paper that the market needs regulation. A regulation vacuum makes product quality a crapshoot, and it raises other concerns. Here's Tara.
There also doesn't seem to be a lot of regulation about where these products come from in the world. And there's not enough known about whether or not things crossing continents and oceans is a good idea or not.
In other words, there could be a risk of introducing invasive species, which is why one soil ecologist I talked to from another lab recently offered me this smart advice for anyone excited about AM fungi but jittery about the commercial options. You can always work on nurturing the soil ecosystem that already exists where you live, because there's probably already fungi in it, native fungi. And yeah, they may be battered and beleaguered from how we've treated the soil for a long time, but there are tried and true ways to help them bounce back. Avoiding herbicides and fertilizer, growing cover crops, cutting back on tilling, etc. In short, even if the mycorrhizae market feels iffy today, for now, you can always love the ones you got. Up From Dust is a production of the Kansas News Service, aka the NPR stations of Kansas, and KCUR Studios. This episode was reported, written, and mixed by me, Celia Yopis-Jepsen, with editing by Mackenzie Martin and Stephen Coranda. A note about the INVAM collection. It actually started at the University of Florida, then went to West Virginia University before finally landing at KU, where it's now part of the Kansas Biological Survey and Center for Ecological Research. The helpful journal article I mentioned early in the episode was A. B. Frank and Mycorrhizae by James Trapp in the journal Mycorrhizae. We'll link to that on our episode page and to our in-depth article about KU's research into commercial fungi products. Big thanks to Suzanne Hogan, Gabe Rosenberg, and Geneviève Demarteau. Jessica Cornelissen is the artist behind our podcast logo. Music provided by David Condos, Tom Lonnie, Milktooth, and Blue Dot Sessions. Effects from Pixabay. Next time on Up From Dust, one family's magical backyard experience just might inspire the rest of us to make changes in our neighborhood too. Till then, thanks for listening.
This podcast sucks, said no one ever, especially not you. After all, this pod is your bestie. You follow it, you listen every time it has something new to say, it goes on walks with you, long road trips even. It's your ride or die. So what are you waiting for? Take this relationship to the next level. Visit kcur.org/support. And thanks.